Welcome, this is CIE 9709, paper 62 of statistics, May June 2010. There are 7 questions which I'll try to solve all the 7 questions. The first question, the times in minutes of 7 students, n is equal to 7, to become a proficient at a new computer game or measure as follows. Find the mean and the standard deviations. The first part, mean. So what are we going to do for finding the mean? Just add all and divide by 7. So I'm adding 48 and 10, then 19, then 14 and 16 divided by 7. Do by calculator, this should be giving you the answer 18.9. Next, the standard deviation is being asked. So it is square root of 15 square plus 10 square plus 48 square plus 10 square plus 19 square plus 14 square plus 16 square upon 7 minus 18.9 whole square. Again, do by the calculator. The simplification will give you 12.3. Coming to the second part, state which of the mean, median, or mode you consider would be most appropriate to use as a measure of the central tendency. Always the median will be used. Why? Because mode is going to be the number which is duplicated more than twice. So mode is always a duplicate number which is repeated or more than twice. So that does not gives you the correct way. Mean also does not shows you because it is an average. We cannot know that how many are more than that number, how many are less than that average. Or for example, when I say mean is 18.9 in this case, I don't know how many people are more than 18.9, how many people are less than 18.9, or at least I don't know that how many have got 18.9. Apart from that, none of them has got 18.9. So mean is of no use at all. So therefore the only best way is median, because I can come to know that median is the middle number. To my right hand side there will be at least 4 or 5 people, and to my left hand side there will be 4 or 5 people. I can know that median is the middle, so that gives much more a bigger picture of the data. Now for each two measures of the average you did not choose in part 2, give a reason why you consider it inappropriate. Just now we have written that mode is because of its duplication problem, and average, it does not shows that how many have got it the higher than the average or how many have got lesser than the average. So average does not gives the number of, does not clearly shows the details of the data. Question number 2, the lengths of new pencils are normally distributed with mean 11 centimeters and standard deviation 0.095 centimeters. Find the probability of the pencil chosen is greater than 10.9. Probability of x greater than 10.9. So convert x into z. Z greater than 10.9 minus x upon mu. Convert x value and mu upon x, not x upon mu. So 1.9, 10.9 minus mu. Mu value is 11 upon sigma. Sigma is 0.095. So I converted x into z by using the formula x minus mu upon sigma. X is 10.9 minus 11 upon 0.095. So probability of z greater than minus 1.0526. Whenever greater than to lesser than is z less than 1 minus I do minus 0.0526. So whenever I convert greater to lesser than, I use 1 minus. One more time 1 minus whenever I convert negative to positive, 1.0526. So 1 minus 1, minus of minus is plus, z less than 1.0526. 1 and 1 gets cancelled. See from the table, normal distribution table, its value will be 0.8538. 3 significant figures, 0.854. Coming to the next part, find the probability that a random sample of 6 pencils, at least 2 have less than 10.9. So I am taking 6 pencils, less than 10.9. Greater than 10.9 was 1.0854, less than 10.9 will be 1 minus 0.854 or 38. To be more specific, it becomes 0.1462. This value will be the success. So failure will be greater than 10.9, which is 0.8538. Now he's asking at least 2. At least 2 means probability of x greater than or equal to 2. When x is greater than or equal to 2 means it is x equal to 3 plus x equal to 4 plus x equal to 5 and plus x is equal to 6. This is very difficult to add it out. So therefore what I do, 1 minus probability of x equal to 0 minus probability of x is equal to 1. So out of 6, 0 should be less than 10.9. So all 6 should be greater than 10.9, which is whole to the power of 6. Out of 6, only 1 should be less than 10.9. So 1462 whole to the power of 1 and 0.8538 should be 5. Simplify from the calculator, you should be getting 0.215. Coming to the third question. The birth weights of the random samples of 900 babies born in a country A, 900 babies born in a country B are illustrated in the cumulative frequency graph. Use suitable data from these graphs to compare the central tendency and the spread of birth weights of the two sets. So first of all, there are 900. So 900 divided by 2 is 450. So I try to find the median. Median for country A, 450. From 450, I draw a line parallel to the x-axis and then try to drop it down. It somewhere comes across 2. So for country A, median is going to be 2. Now country B, also 450. I draw a line and try to drop it down at 450. This is something around 3.8. The median is going to be 3.8. So we can say that the middle person's weight or the birth weight is 2 for A, and whereas for B is 3.8. So we can say that country B has heavier babies. Now calculate the spread. For calculating the spread, we have to calculate Q1 and Q3. So first I will do Q1. Q1 is 900 divided by 4, which is nothing but what? 225. From 225, I am going to draw the line. Each line indicates 20, 20, 40, 60, 80. When you zoom it, you can see that each line indicates 20, 20. We can make it and check that. It becomes 20, much more shorter. So it becomes 40, 60, 80, and 300. So one line is 20 units. So I want 225. So what am I going to do? From 225, I am going to draw a line, approximate line to the country A graph and drop it down. So I can see that it is 1.5 for country A. Q1 is equal to 1.5. Simultaneously, I can draw for country B also. Same line, drop it down. It should be 2.2. For country B, Q1 is equal to 2.2. Now I'm going to find Q3 is 3 upon 4 times 900, which is 225 times 3 is 675. So from 675, so we know 20, 40, 60, and 80. So 675, draw a line, then drop it down. So it should be something around 2.4. So Q3 is equal to 2.4. So interquartile range, immediately find it out, which is Q3 minus Q1, which is 2.4 minus 1.5, which is 0.9. Now for country B also, from same 675, drop it down, it becomes 4.5. Q3 becomes 4.5. So my interquartile range is going to be Q3 minus Q1, which is 4.5 minus 2.2, which is equal to 2.3. So we can see that there is a bigger spread in case of country B. So we can say that country B has greater spread of weights. Question number 4. The random variable x is normally distributed with a mean mu and standard deviation sigma. Given that 5 sigma is equal to 3 mu and find probability of x less than 2 mu. Probability of x less than 2 mu. Convert x into z less than 2 mu minus mu upon sigma. Probability of z less than mu upon sigma. Mu upon sigma, because he has given that 5 sigma is equal to 3 mu. So divide by sigma on both sides. So 5 is equal to 3 mu upon sigma. So mu upon sigma is nothing but what? 5 upon 3. So probability of z less than 5 upon 3. Find a different relationship between mu and sigma given that the probability of x less than 1 upon 3 mu is equal to 0.8534. Probability of x less than 1 upon 3 mu is equal to 0.8524. So probability of z less than 1 upon 3 mu minus mu upon sigma is equal to 0.8524. So probability of z less than minus 2 by 3 mu upon sigma is equal to 0.8524. See from the table, this value will be 1.047. So from there, making mu as subject, so we get minus 1.047 times 3 upon 2 sigma, which is going to be minus 1.57 sigma. That's going to be the answer. Coming to question number 5, two fair 12-sided dice with the sides 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 are thrown, and the numbers on the sides which land face down are noted. Events Q and R are defined as follows. Q is the product of two numbers is 24. 24. So 1, I cannot get a number which makes it 24 out of 1 to 12. It should be 2 and 12 gives me 24. 3, 8 gives me 24. 4, 6 gives me 24. 5 is not possible. Then 6, 4 gives me 24. 8, 3 gives me 24. And 12, 2 gives me 24. So totally how many ways are there? 7 ways are there. Now, because the first dice can give you 12 and the second dice also can give you 12. So there are 6 ways. 1, 2, 3, 4, 5, 6, not 7 ways. So there are 6 ways. 1, 2, 3, 4, 5, 6 ways. 6 upon 12 times 12, which is nothing but what? 6 upon 144. So you can write it as 1 upon 24 or 0.0417. Next part, what is that? R. Both the numbers are greater than 8. So I want the first number also to be greater than 8 and the second number also to be greater than 8. First number, second number. So the numbers which are greater than 8 are nothing but what? 9, 10, 11, 12. So it can be any 4 numbers out of those 12 and 4 out of those 12. So it has to be nothing but what? 1 upon 3 times 1 upon 3. Probability of R. So that's equal to 1 upon 9. Then are the events Q and R exclusive? So for exclusive, probability of R intersection Q should be equal to 0. Do we have any number? So what are the numbers? We took these options for P, for Q, and according to R, this is for P, according to R, number should be greater than 8. Both the numbers should be greater than 8. So this is not greater than 8, not greater than 8, not greater than 8, not greater than 8, 4, 6, not greater than 8, not greater than 8. None of them are greater than 8. So there is nothing common, what it says, which is greater than 8. So probability of Q intersection R is equal to 0. So they are exclusive. Now, are they independent? Justify your answer. So for independent, probability of R intersection Q should be equal to probability of R times probability of Q, which is equal to 0. Probability of R is 1 upon 9, and this is 6 upon 144. We can say that it is never be equal to 0, so therefore they are not independent. Question number 6. A small farm has 5 ducks and 2 geese, 4 of these birds to be chosen. The random variable x represents the number of geese chosen. So we have 2 geese, x represents number of geese. Draw a probability distribution table. So number of geese to be chosen. So I have 2 geese. So maximum it can be 2 geese. So it can be 0 geese, 1 geese, or 2 geese. So this should be the probability distribution table. So let us draw once again bigger one, because I feel that some calculations are to be done. So therefore I'm drawing the bigger one. So 1 geese, 0 geese, 1 geese, and 2 geese. So this is x, 0, 1, 2. Probability of capital X is equal to small x. If 0 geese means, so first of all I have 7 birds. So out of 7, 4 can be chosen in 7C4. So it is 7C4, but it should be 0 geese, means all 4 should be from the ducks, 5C4. Then the next one is, still it is 7C4, but I choose 3 ducks and 1 geese. And the next one is still 7C4, but I choose 2 ducks and 2 geese. Now, when I simplify by the calculator, this value gives me 1 upon 7, this value gives me 4 upon 7, and this value gives me 2 upon 7. Show that expected value is 8 upon 7 and find the variance of x. So expected value of x is nothing but what, sigma xpx. So 0 times 1 upon 7 plus 1 times 4 upon 7 plus 2 times 2 upon 7, which is going to be 8 upon 7. Now variance of x is equal to sigma x square p of x minus expected value of x whole square. So I find expected value of x whole square. So which is 0 squared times 1 upon 7 plus 1 squared times 4 upon 7 plus 2 squared times 2 upon 7 minus 8 upon 7 whole square. Simplify that, you should be getting the answer as 20 upon 49. Finally, when the farmer's dog is let loose, it chases either ducks with a probability 3 upon 5 or the geese with a probability 2 upon 5. So, it chases a duck or a geese. Probability is 3 upon 5, probability is 2 upon 5. If the dog chases a duck, there is a probability that 1/10 that they will attack the dog. So, they will attack the dog. Attacking, not attacking is 1 upon 10. So, not attacking will be remaining 9 upon 10. 1 minus 1 upon 10 is 9 upon 10. If the dog chases a geese, then there is a probability that 3/4 that they will attack the dog. When geese, 3/4 of them will be attacking the dog. So, I get over here attacking, not attacking, 3/4 attacks. So, remaining 1/4 will not attack. What is he asking? Given that the dog is not attacked. Given that the dog is not attacked. So, whenever we have like this, given that questions, write the denominator first. probability of not attacked. So what is the probability of not attacked? It can be either be from dog and not attacked, or it can be from geese and not attacked. But what should I do? Find the probability that it was chasing the geese. So it was chasing the geese. So geese part will goes to the numerator. Probability of geese intersection A complement. So which one is the geese one? 2 upon 5 times 1 upon 4. That goes to the numerator. So write the denominator first. So he says not attack. So not attack, write the denominator. A part of it should go to the numerator. Which part? Before given that, whatever the question is there, he is asking about it is being attacked by geese. So we are considering with respect to geese. Simplify that. You should be getting the answer 5 upon 32. Write the denominator first, a part of it goes to the numerator. Last question, question number 7. 9 cards, each of different color, are to be arranged in a line. How many different arrangements 9 cards can be done? Just 9 cards can be arranged in 9 factorial ways, which is 3, 6, 2, 8, 8, 0. The 9 cards include a pink and a green card. How many different card arrangements do not have pink and a green card together? So they don't want together. So what I will do, I'll take the total and subtract together. I'll try to find how, if at all, they are together. So out of those 9 cards, 9 units, I take away that pink and green 2 units. And what do? I tie them as one block, 1 unit. So how many I get it out? I'll be getting it out 8 units. This 8 units can be arranged in what? 8 factorial. This PG can be arranged among themselves in 2 factorial. So this becomes 80,640. So what does this 80,640 indicates? This indicates that PG are together. But the question is asking that they should not be together. Not together. So what should I do for not together? It should be the total number of ways minus together is going to be the not together. Total is nothing but what? 362,880 minus 80,640. So simplify that, it should become 282,240. Consider all possible choices of 3 cards from the 9 cards, and 3 cards are arranged in a line. Find how many different arrangements in total 3 cards are possible. So what am I doing? I'm arranging them. So I choose out of 9, I choose 3 and arrange them. So 9p3. If at all it is arranging, it is 9p3. If at all it is just only choosing, 9c3. But he says it is arranging, so 9p3. Then don't forget to multiply by 3 factorial. Once you find them, choose them and arrange it out, it can be done in 3 factorial. But this 3 factorial has to be done if I'm doing with 9c3. If 9p3 is considered, already that 3 factorial is there. So either you do 9p3 or 9c3 times 3 factorial. For combinations, the arrangement is not included, therefore I multiply with 3 factorial. But for permutations, the arrangement is already included, so no need to multiply with 3 factorial. So either it is 9p3 or 9c3 times 3 factorial, which is 504. So this 504, those 3 cards can be arranged, chosen and arranged. That's question number 3. Question number 4. How many of this arrangement, 3 cards in part 3, contain a pink card? So I'm choosing a pink card. So out of 9 cards, 1 card has been already chosen, which is a pink card. So 8 more cards are there. And I have to choose 2 more. So it can be done in 8c2. Once I get this 8c2, I can arrange this one in 3 factorial ways. We are arranging. So 8c4, 8c2 times 3 factorial, which is becoming 168. Finally, how many arrangements of the 3 cards in part 3 do not have pink card next to the green card? So what am I going to do? I am going to take it out pink and green together. So 3 cards, right? Pink, green. So the third card, I'm left over with third card. So 9 cards will become 7 cards because I'm choosing pink and green. So this can be filled in how many ways? 7 ways. Then it can be pink green 7, green pink 7, and pink, green 7. So total how many ways? 4 ways. So 7 times plus 4 times. So which is nothing but what? 28 ways. So there are pink and green together in 28 ways out of those 3 cars. But I don't want not together. They should be not together. Not together, what should I be doing it out? Total minus together. Total is nothing but what? 504. Just now we have done. Together is 28. 504 minus 28 is 476. So not together will be 476. So whenever not together is being asked, the easiest way of doing it is find the total and subtract the together one. So the remaining will be not together. So that completes the paper. See you in the next paper. Bye.